Okay, so we're looking at question 20 on this worksheet here, angles of elevation and depression. So, an airplane is flying at an altitude of 10,000 feet. The airport at which it's scheduled to land is 50 miles away. Find the average angle at which the airplane must descend for landing. So that's an angle of depression. Find your answer, round your answer to the nearest degree. So, let's start by drawing this out. Draw a little airplane. Like that. And we know that it's 10,000 feet above the ground. Start right there. Say that's 10,000 feet. And we know that the airport is 50 miles away, so this is not going to be to scale, right? Because 50 miles is way more than 10,000 feet. We'll just do it like that. So we're wondering from, and I'm going to draw this line eye level to the plane because that's important when you're dealing with angle of depression or angle of elevation. I'll just draw this a straight line. So this being that same amount as that bottom line, 50 miles, we need to know this angle right here between the airport and the plane. So let's see if I can connect that. That'll do just like that. Okay. So we're looking for this angle right here, x degrees. And we are given one side of the triangle, one of the legs, and we are also given, and I'll draw this, finish this triangle off. It's actually congruent to the other triangle, if you think about it. This side as well, which is 10,000 feet. 10,000 feet. So we can see with this blue triangle we can use trigonometry, specifically inverse trigonometry, to find that angle measure. So one of the most difficult parts here is to change either 50 miles into feet or 10,000 feet into miles. I think it might be easier to deal with miles since they're smaller numbers. So how many feet are in a mile? That is, if you look it up, 5,280 feet per mile, and we have 10,000 feet. Now if we take 10,000 divided by 5280, we get approximately 1.894. So I'm going to put this aside and say 1.894 miles. Now, which trigonometric ratio we're going to use? We have the two legs, nothing to do with the hypotenuse, so we'll use tangent. So we know that tan of angle x is equal to the opposite side, 1.894, over the adjacent side next to the angle that's not the hypotenuse. So over 50. Now we can use the inverse, tan inverse 1.894 over 50 to determine that angle. So I'll type that in. Tan inverse 1.894 divided by 50. We get 2 point, let's see, it says round to the nearest degree, so whole number, 2.16 rounds to 2, so we have 2 degrees. That's an angle of depression.